You're going to be able to use the same 4 steps that I'm about to show you to graph a cubic function to graph just about any polynomial function. But it's going to behoove us, before we do that, to look at those 4 steps to see what's different about a cubic function than from a quadratic function. Remember that a quadratic function is one of these x squared, or it has an x squared in it somewhere, whether it's a positive x squared or a negative x squared. And what happens when you square something is, well, if you square a negative number, like the negative x's on the left side there, they're going to end up being a negative times a negative. They're going to end up being a positive, so it's going to go up. And even if you square a positive number, it's still going to stay positive, isn't it? So if we go to the right side, we're going to have what you, of course, know as to be a parabola. Now, on the other side of this, if we have a negative x squared, we're going to do the exponent first. We're going to do the x squared first, and on the negative side, we'll get a positive number, but then it'll become negative, so it'll point down. And even if we square a positive number, it's still going to, in this case, stay negative, because the last thing we'll do with this function is make it negative. So with a quadratic function, if it's a positive, it stays positive, and if it's a negative, it stays negative, because of the squaring, the even number of negatives. It results in keeping the sign the same. Now, with a cubic, it's a whole different animal. You have an odd number of negatives, no matter what. You have 3 negatives. Now, on the red side, of course, we'll have a 4th one. But let's look at the blue function, the positive x to the 3rd. That's going to be an odd number of negatives when we're on the negative side. But when we have on the positive side of x, it's going to switch signs, because we're going to have an, well, we would have had an odd number of negatives, but on the positive we have no negatives. So it's going to go the other way. It's going to switch signs, isn't it? An odd number of negatives will always switch signs. Even if it's a negative odd number of negatives, that's going to be positive, but then when we go to the positive side, it's going to switch signs. Point being that a cubic will always have a place somewhere in that graph where it's going to switch signs, or it's going to take a turn, if you would. Okay, be aware of that when we go to actually sketch the graphs.
Let's play. Here we go.
Let's try it. Let's look at the 4 steps. The first thing we'll do is find where the graph hits the x-axis. Now look at the x-axis. What is the value of y for any point that's actually on the x-axis? Well, it's 0. So we can find all the x-axis intercepts by setting y equal to 0. Y, of course, is f of x. So let's set y equal to 0 and solve this equation. Now, typically I'm going to give you ones that are solvable using the 0 property. I'm going to factor this, taking out an x squared, and we'll factor this portion, taking out a minus 4, and sweetly I see that there's 2x plus 1. So let's take out an x plus 1, as you can see, and I'll have x plus 1 times x squared minus 4, won't I? Now x squared minus 4 is a difference of 2 squares, so I'll factor that into x plus 2x minus 2, which means, using the 0 property, the roots of this equation are negative 1 for this factor. So there's one x-intercept.
Are you pondering what I'm pondering?
Negative 2 for this factor. And the third one, x has to be a positive 2 to make it 0. So those are your 3 x-intercepts. That's the first step. Now we found the x-intercepts.
Now what am I going to do?
The second step is to find the y-axis intercepts. Now the y-axis intercepts occur when x equals 0. They're generally a little easier to find, because all we have to do is put in 0 for x. And all the zeros kind of cancel, don't they? And in this case, there's only 1. Apparently, the y-axis intercept is at -4. Okay, that's step 2.
I'm trying to think, but nothing happens.
Step 3. Well, now we're going to select other, what I would call critical points, and this is the tough part, to find that spaghetti shape, if you would. Okay, what are critical points? Well, the first critical point, I want to know how am I going to get from, on this graph, from maybe from this point to this point. So I need to pick an x that's between those two. Does it go straight to that point, or does it go down first and then come up, or what does it do? Well, the only number or value that's between those two is 1. So let's plug in a 1 and see what happens.
Certainly.
If we put in 1 into this equation, in every occasion of x, I get -6. So I know the point 1, -6 is on there, and let's plot it. Well, it has to go by that point to get back up to the other. Another area of this graph that I have no idea which way the line goes is this area in here. I want to know where it goes after it hits that left red point. Does it go up or does it go down? So let me pick any one of these points. I'm going to pick what I think is the easiest one. I'll pick -3. Let's go ahead and put in -3 and see what happens at that spot. Putting in a -3, I can do that with my calculator if I wish, but putting it in, trust me, you get a -10. So the point -3, -10 is going to reveal to me kind of the direction of my graph. And there's -3, -10. Now you got to be looking for that change of direction. If you can find any other critical points that you need, but I think at this point, if I know my cubic curve well, I can find that curve. Take a look. There's the cubic curve, the change of direction. Okay, now you got to get good at this, but that's why I told you, remember that a cubic always changes direction. Okay, let's try another one, and hopefully you'll see that we can use the same 4 steps. You remember the first step? Well, I'll tell you. The first step is to find the x-axis intercepts. Now, where does that occur? The x-intercepts occur when y is 0. So I put in a 0 for y, and I solve the equation. Let me factor here. I'll factor out the greatest common factor, which is x. And then once again, I have a difference of 2 squares. And I'm going to have, shouldn't surprise you, 3 answers here using the 0 property. One of them is where x is 0. Another one, what makes this 0 is -3. So there's another x-intercept. And the other one is where x is 3. Okay, so those are my 3 x-intercepts, or roots, if you would. The second step is to find the y-axis intercept, or intercepts. Now that's a little easier, remember, because all I have to do is find out where x equals 0, or plug in a 0 for x. I love 0. He's easy to solve. 0 to the third minus 9 times 0, guess what? It equals 0. So in this case, the y-axis intercept happens to be also one of the x-axis intercepts, doesn't it? Now we know we're going to draw a continuous line that crosses these 3 points, and it's going to change direction because it's a cubic. We just don't know where it is. So I think this is a better example of finding critical points. Okay? Easy x values that tell you which direction the line you would draw is going to go. The first area I would try to guess that I need to get a point in is going to be this area. Okay, something in there. I have to know how that blue gets to that red. Does it go up or does it go down? So I can use either 1 or 2.
Correct. Boy,
Let's just use 1 to make life easier. So plug in 1, and we get 1 to the third minus 9. I get negative 8. So the point 1, negative 8 is down there, and I can see kind of where my curve's going to be. Now there's another critical area between these points. How about in here, what happens? Well, I can either put in negative 1 or negative 2. Let's just put negative 1. And if I put that in, I get positive 8. So let's graph that one. Now you have to draw a continuous line, and you may already know where it is. But just for the sake of argument, let's put in a couple more critical points, if you would. How about something in this area, so we can see which direction things are going? Well, I'll choose negative 4, and I get negative 28. Now watch where the point goes. Negative 4, negative 28. It's way down there. Did you miss it? And if I do something over here, positive 4, I get positive 28, and that's, watch it go, that's way up there. So I can see the trend of this line. It has to be continuous from left to right.
Are you pondering what I'm pondering?
To sketch the cubic curve that changes direction, it's going to have to be there it is. Now you can always check your answer, of course, with your graphing calculator. Remember how to do that? You turn it on, hit y equals, and then clear out anything you did before, perhaps, hitting clear button. And then type in whatever the function is, in this case x to the third minus 9x. And what do you hit? Hit graph, and there it is. Okay, and you can get out of it by hitting clear. So use your graphing calculator to check your answers, but I am going to expect you to give me the x-axis intercepts, the y-axis intercepts, and the critical points as well. So you can't just use your calculator to do the whole thing. So go practice.